Hello and welcome back to Neo Psychology with me, your teacher, Mr. Neo, the channel where I teach you psychology lessons to my wonderful students. Today we are carrying on with Biopsychology and we're having a look at lesson 4, functional recovery of the brain after trauma. Last lesson we had a look at brain plasticity. Now we're looking at the functional recovery. How does the brain recover after a trauma? Let's get started, shall we? There we go. Starter. As we learned in lesson 1 and 2, certain brain functions are localized to specific areas of the brain. For example, the motor cortex is a region of the frontal lobe involved in regulating movement. Sometimes, if someone has a head injury or a stroke affecting their frontal cortex, it can paralyze them from walking. But somehow, even without function to their motor cortex or to that specific section of their motor cortex, they can relearn how to walk again and recover function, right? Functional recovery. They're recovering that function. How does this happen though? How on earth can this happen? That part of their brain has been destroyed through an injury or through a stroke. But somehow, and as a result of that injury, they've lost their ability to walk. But somehow, even without that specific area of the brain, you can relearn how to walk again. How does this happen though? This is what we're looking at today. So here's our learning objectives. Show comprehension and apply knowledge of functional recovery of the brain after trauma. 2, identify and analyze mechanisms for recovery. And then 3, to be able to discuss and evaluate functional recovery of the brain after trauma. So let's start with LO1. Show comprehension and apply knowledge of functional recovery of the brain after trauma. Last lesson, we learned about brain plasticity. The brain's tendency to change and adapt functionally and physically as a result of experience and new learning. One form of brain plasticity is functional recovery, right? It's a form of brain plasticity. It's recovering functions. Functional recovery is the way that certain abilities of the brain may be moved or redistributed rather than lost following damage or trauma, e.g., like a stroke to the brain. In the 1960s, researchers studied cases in which stroke victims were able to regain functioning. They discovered that when brain cells are damaged or destroyed, as they are during a stroke, the brain rewires itself over time so that some level of function can be regained. Although parts of the brain may be damaged or even destroyed as a result of trauma, other parts of the brain appear to be able to take over the functions that were lost. Neurons next to damaged areas can form new circuits that resume some of the lost function. How good is the brain? Well done, brain. Let's try and fill in the gap for the definition. Functional recovery. What is functional recovery? Functional recovery is a form of, fill in the gap, do it with me, do it before me if anything, a form of plasticity, good, following damage through brain injury or disease, the brain's ability to redistribute or transfer functions usually performed by a damaged area to other undamaged areas. Good. Functional recovery is a form of plasticity. Following damage through brain injury or disease, the brain's ability to redistribute or transfer functions usually performed by a damaged area to other undamaged areas. How good is that? Identify one thing you learned about functional recovery of the brain after trauma. What's one thing you learned just now? You learned loads just now because I'm a great teacher. Why do you think learning about functional recovery of the brain after trauma is important? Why is it important to know this, right? And how does it apply in real life? How is it useful? When am I ever going to use this? What questions has functional recovery of the brain after trauma raised for you? What are you still wondering about? You got any questions you don't understand? Go over it again, have a look in the textbook, or write them down and ask me, or ask your other fellow students. But there we go, learning objective 1. Show comprehension and apply knowledge of functional recovery of the brain after trauma. Learning objective 1, you happy to tick it off? You're not. I'm ticking it off anyway. There we go. Learning objective 2. Identify and analyze mechanisms for recovery. What is this? Not sure. Let's have a look. Mechanisms for recovery. Regenerative developments in brain function arise from the brain's plasticity, its ability to change structurally and functionally following trauma. Two ways in which the brain is able to do this are neuronal unmasking and stem cells. We're going to have a look at what those two are now. This is neuronal unmasking. Wall first identified what he called dormant or inactive synapses, right? A synapse is the connection between two neurons, right? So it's the dendrite of one and it's the axon terminal of another, and they're connected to make a neuronal pathway. So Wall first identified what he called dormant or inactive synapses in the brain. These are synaptic connections that exist anatomically, so they're there, but their function is blocked. They are not being used, nothing is going through them. There is no electrical current or no chemical current going through it. There's no messages being sent through it. Under normal conditions, these synapses may be inactive because the rate of neuronal input to them is too low for them to be active. So they're almost like they're dead, right? They're inactive neurons. You can see them here. They're not very happy. They're not very happy. They're not being used, right? There's two connections, but there's nothing going through them, so they're basically dormant, all right? They're inactive. But what can happen? Neuronal unmasking, however, increases the rate of input to these synapses, as would happen when a surrounding area becomes damaged, can then open or unmask, which is neuronal unmasking, these dormant synapses. The unmasking of dormant synapses can open connections to regions of the brain that are not normally active or not normally activated, creating a lateral spread of activation, which in time gives way to the development of new structures. Look how happy they are now. They can send their messages. The brain is able to rewire and reorganize itself by forming new synaptic connections, right? This is neuronal unmasking, close to the area of damage, a bit like avoiding roadworks on the way to school by finding a different route, okay? So the section has been damaged, right? It might be brain disease, it might be physical damage, right? And then that part isn't working. So the brain finds a reroute. It reroutes it through old synaptic connections that aren't being used, and it reawakens them, and it means that you can go through that now. And it's found an alternative diversion route to get to what it wanted to do. How impressive is that? The alternative is also stem cells. So stem cells are unspecialized cells that have the potential to give rise to different cell types that carry out different functions, including taking on the characteristics of nerve cells. There are a number of views on how stem cells might work to provide treatment for brain damage caused by injury or neurodegenerative disorders. So a stem cell, essentially, it's an unspecified cell. It's an unspecialized cell. It can be anything. It can essentially change into any cell that is needed in that specific part of the brain. The first view is that stem cells implanted into the brain would directly replace dead or dying cells. And then a second possibility is that transplanted stem cells secrete growth factors that somehow rescue the injured cells. So the stem cell comes in and one, it replaces dead or dying cells itself, as well as secreting growth factors, and it helps rescue the injured cells. Okay, here's a question. Research methods. The case of Gabby Giffords. Gabby Giffords, GG, is a former US Democratic politician who survived an assassination attempt in 2011 when she was shot in the head from point blank range. Oh, America is so messed up. Doctors placed Giffords into a waking coma, such was the critical nature of her condition. Within months, however, she had made staggering progress. With the aid of physical rehabilitation, Giffords was able to walk under supervision with perfect control of her left arm and leg, and was able to write with her left hand. She could read, understand, and speak in short phrases. Doctors suggested that Giffords' progress would place her in the top 5% of people recovering from serious brain injury, a remarkable example of the brain's ability to heal itself, right? So it was absolutely incredible that Gabby Giffords actually managed to survive, and not just survive. She didn't survive and was in a coma for the rest of her life and was bedridden. She actually had the ability to walk with rehabilitation and to write and to move many parts of her body, as well as having relatively good mental faculties. Question. With reference to the example of GG above, my girl GG, briefly discuss strengths and limitations of the case study approach. A case study is a one-person sample. It's when you've got one person and you usually do a really in-depth analysis on that situation. What's the good thing about doing case studies and what's the bad thing about doing case studies? Here it is. Answer. A strength of case studies is that the individual can be studied in great depth over a long period of time, and we can see changes rather than just a snapshot. Gabby was able to be studied longitudinally, which is over a long period, to see the progress she made in terms of recovery. This kind of research cannot be studied experimentally, as it would be unethical to damage someone's brain to see how it recovers, right? So it's an experimental thing, because we're doing research on someone that's already got the brain damage. You can't go and get a sample of 20 people and give 10 of them brain damage just to do your thing, because it's unethical. So you do it with people that have already got that. However, a limitation of case studies is that it cannot be generalized from one individual to many people, right? Just because Gabby showed remarkable progress and recovery doesn't mean that other individuals or all individuals in the situation would also. For example, Gabby might have particular personal qualities related to determination, which meant that she did recover from the same, but the same would not be true for everyone. Okay, it's a case study. It's a one-person study, right? It's really annoying, like when that person tells you, "Oh, I've got an uncle who smokes and he lived until he was 90." Well, good for your uncle, but it doesn't mean smoking's not bad for you, you idiot. Right, so that was mechanisms for recovery. Identify one thing you learned about mechanisms for recovery. What's one thing you learned about? Why do you think learning about mechanisms for recovery is important? How does this apply in real life? How is this useful in everyday life? And again, you got any questions? Write them down, put them in your notes, ask me, put your hand up in lesson. I didn't get this. Can you explain it? Of course I can. I will do. There we go. That's learning objective 2. Identify and analyze mechanisms for recovery. Right? We understood that. Good? Yes? Tick it? Tick it. Done. Learning objective 3. To be able to discuss and evaluate functional recovery of the brain after trauma. We're going to evaluate this. Evaluation AO3. Here we go. What are some of the strengths and weaknesses of functional recovery of the brain after trauma? Research support from animal studies. Tajiri et al. In 2013 provided evidence for the role of stem cells in recovery from brain injury. They randomly assigned rats with traumatic brain injury to one of two groups. One group received transplants of stem cells into the region of the brain affected by traumatic injury. The control group received a solution infused in the brain containing no stem cells. 3 months later, the brains of the stem cell rats showed clear development of neuron-like cells in the area of the injury. This was accompanied by a solid stream of stem cells migrating to the brain site of injury. This development of new neuronal cells was not evident in the control group, supporting the important role played by stem cells in recovery from brain injury. So, is this a strength or a weakness? This is a strength because it's supporting the idea that stem cells can help recover function in the brain after a trauma. The concept of cognitive reserve. Evidence suggests that a person's educational attainment may influence how well the brain functionally adapts after injury. Eric Schneider et al. In 2014 discovered that the more time brain injury patients had spent in education, which was taken as an indication of their cognitive reserve, the greater their chances of a disability-free recovery. 2/5 of patients studied who achieved disability-free recovery had more than 16 years education compared to about only 10% of patients who had less than 12 years recovery, or less than 12 years education. What other factors may influence how well a person recovers from brain injury? I'd say like motivation. First of all, is this a strength or a weakness? It's a strength, I'm assuming, because it's showing you how the cognitive reserve, how that, depending on who you are and how much motivation you have, and how much cognitive reserve you have, it depends on how good of a recovery you have. Right, what other factors may influence how well a person recovers from a brain injury? Other factors that may affect a person's recovery after a brain injury may be the severity of the injury. Yeah, if it's a really severe injury, then in comparison to a minor injury. The age of the person, how quickly they are treated, how they respond to treatment, and if they have any other pre-existing conditions. There are lots of things that might affect how well a person recovers. Okay, outline one strength and one weakness of functional recovery of the brain after trauma. Answer the question, appeal paragraph structure. And there's the evaluation. Identify one important thing you learned from the evaluation. Why do you think learning about the evaluation is important? How does the evaluation apply in real life? And what questions has the evaluation raised for you? What are you still wondering about? You got any questions about the evaluation? Let me know. That's the evaluation, to be able to discuss and evaluate functional recovery of the brain after trauma. Let's tick that one off. Yes, we're done. With the exception of the plenary. Plenary, we've got some questions again. Multiple choice questions, right? I'm going to answer them with you. Answer them before I do, though. Okay. Number 1. The deleting of rarely used connections in the brain is known as A. Synaptic priming. B. Synaptic plumbing. C. Synaptic pruning. Or D. Synaptic planning. Did you say synaptic plumbing? Well, it'd be wrong, because it's pruning. C. Well done. I know you got that one right. Number 2. In the Maguire et al. Study of London taxi drivers, which area was seen to have undergone learning-induced changes? Ooh, which one was it? Was it A, the posterior hippocampus? Was it B, the anterior hypothalamus? Was it C, the anterior gyrus? Or was it D, bacteria epiglottis? It's got to be the hippocampus, surely. I'm going hippocampus. Yee. 2 out of 2. Doing well. Number 3. Which of the following refers to the activation of secondary neural pathways to carry out new functions? Is it A, revealing? B, unmasking? Don't unmask. Be safe. Keep a mask on. C, unearthing? Or D, renewing? Which one is it? What did you say? B, unmasking. Really? No, you're right. Unmasking, B, good. Number 4. As we age, rarely used connections are deleted and frequently used connections are strengthened. This is known as what? A. Synaptic pruning. B. Synaptic regeneration. C. Neural plasticity. Or D. Axonal sprouting. Ooh, it's difficult. And of course the answer is A. Synaptic pruning. Number 5. Complete the sentences by connecting each of the sentence halves. So, here are the sentences. People who have spent more time in education, 2/5 of patients who achieved a disability-free recovery, and 10% of patients had a disability-free recovery if they. And then the options are, had less than 12 years education, have greater cognitive reserve as an increased chance of a disability-free recovery after injury, and the last one, had more than 16 years education. Right, let's have a go. People who have spent more time in education have greater cognitive reserve, I'm going to go for. Yes. Second one, 2/5 of patients achieved a disability-free recovery, had more than 16 years education, and then 10% of patients had less than 10 years education. Done. Good. The final one, number 6. I might have put more, I can't remember. Connect the terms of the correct descriptions. We've got the parietal cortex, we've got the posterior hippocampus, we've got axonal sprouting, and we've got synaptic pruning. Ooh, this is difficult. As we age, rarely used connections are deleted and frequently used connections are strengthened. That sounds like pruning. Growth of new nerve endings that connect with other undamaged nerve cells to form new neuronal pathways. Sounds like axonal sprouting. Maguire et al. Found this area of the brain had more grey matter in taxi drivers. Hippocampus, surely. And then Michelli et al. Found this area of the brain has larger in bilingual people. Parietal cortex. So we're going 1 is to 4. 2 is to 3. 3 is to 1, 2. That's what I said anyway. I said that. And synaptic pruning is the first one. There we go. How did you do, right? How many questions did you get correct out of 6? Are you an absolute legend? Got 6 out of 6. Check out this article about Gabby Giffords if you want to find out a little bit more about her and a little bit more about her tendency. But there we go. There is the end of the lesson. Thank you for joining the lesson. Today was lesson 4, functional recovery of the brain after trauma. Be sure to write up your notes for next lesson. Well done, my neo-psychologist. Great work today. You've been brilliant. I've been Mr. Neo. God bless and peace.
I'm feeling like Will. I feel like a prince. I'm feeling myself. I'm loaded with bills, cause I wasn't blessed with no Uncle Phil. Don't know how it feels. I wanted to flex, they told me to chill. I'm making a flip. My life is a flick, now load up the film.